Year 10 Indices, Raising Terms Involving Indices to Another Index. Lesson 2. Now, the examples we're going to look at in today's lesson involve what you may have heard described as a power of a power. So let's go straight into a few examples. I'm going to start with x squared. There's x with an index of 2, and I'm going to imagine that we raise this to the power 3, like that. Now let's remind ourselves of what cubing actually means. It means we take x squared and we multiply it by itself, like this. So x squared multiplied by x squared multiplied by x squared. Now, in the previous lesson, we recapped what you've already learnt about multiplying terms. We know that we can add the indices. So this becomes x to the power 6. Now, you may remember this from work you've done previously, but of course, that 6 can be found by simply multiplying the two indices here. So 2 times 3 gives you the overall power of 6. Let's have a look at another example. Let's suppose this time I have 5 cubed and I want to square it. So this means I take 5 cubed and I multiply it by 5 cubed. Again, if I add my indices, this gives me 5 to the power of 6, which I could have found by multiplying the indices here. So let's try another example. We've got 3 to the power of 4, all to the power of 3. Now, let's predict the answer by multiplying the indices. So that would give us 3 to the power of 12. And let's just check it by writing it out. So that's 3 to the power of 4 multiplied by 3 to the power of 4 multiplied by 3 to the power of 4. And of course, 4 add 4 add 4 is the same as 3 times 4, it's 12. So we've got to our answer. So we can write down another rule for working with indices. We can say that if we have x raised to an index a, and then the whole thing raised to an index b, this is the same as x to the power of a b, or x to the power of a multiplied by b. And this joins the other rules that we've already seen. Let's try some harder examples. So here I have 5 to the power of 3 raised to the power of negative 2. Now, again, we're going to recap negative powers and negative indices a little bit later on, but for the moment, we can use the rule that we've looked at where we multiply our indices together, and this becomes 5 to the negative 6. Now, let's try this example. I have 2x to the power 4 all to the power 3. So 2x to the power 4 all to the power 3. Now, be very careful. Let's write this out in full, because what we have is 2x to the power 4 multiplied by 2x to the power 4 multiplied by 2x to the power 4. And you looked at some examples like this in the last lesson. We need to make sure we remember to multiply 2 by 2 by 2 to give us 8. And then we need to make sure we look at the x to the 4 multiplied by x to the 4 multiplied by x to the 4, which gives us x to the power 12. So yes, we do multiply these indices here. 4 multiplied by 3 gives us the power of x as 12, but we mustn't forget to raise the 2 to the power 3. So this must be raised to the power of 3 as well as the x to the 4. Let's try another similar example. So this time I've got 5a to the power of 7 all squared. So let's write out in full. We have 5a to the 7 multiplied by 5a to the 7. We know that 5 multiplied by 5 gives us the 25 that we need at the start, And then a to the 7 multiplied by a to the 7 gives us a to the power of 14. So the 7 and the 2 have been multiplied together, but the 5 must be raised to the power of 2, or squared, as we could also say. Let's try one more of these. This time we've got 2p to the power of 11, all raised to the power of 3. So remember that the p is being raised to the power of 11, not the 2, but both parts of this, we can sort of separate them out like that, are being raised to the power of 3. So we're going to straight away go for writing out the answer. 2 to the power of 3 we know is 8. Then we need to do p to the power of 11 to the power of 3, multiply the indices, 8p to the power of 33. If you want to, you can write out the calculation in full, so you can see all parts of that multiplied together like that. Now we're just going to quickly look at two slightly different examples about which we need to be careful, because I've seen people making mistakes on these sorts of questions before. So, my first example is this: 2x to the power of 3, all raised to the power of 3. Now, let's write it out. So that is 2x cubed, 2x cubed, 2x cubed. And these three terms are being multiplied together. That's what cubing means. So we can see the 2, the 2, the 2 here, all multiply together to give us 8. And we can see x cubed multiplied by x cubed multiplied by x cubed, which gives us x to the power of 9. We could also see that from here, multiplying these indices here, 3 times 3 is 9, and we can also see that 2 has been cubed to give us the 8. Now, this is a different question. Have a look at example 2. Example 2, I've got 2 cubed all to the power of 3. Now, look at the difference between the two questions. In the first question, you simply have a 2 inside the bracket. In the second question, you have a 2 cubed inside the bracket. So when we multiply the powers together, we get an answer of 2 to the power of 9. If you want to write out in full, you have 2 cubed multiplied by 2 cubed multiplied by 2 cubed. And you can add your 3 indices here. 3 plus 3 plus 3 is 9, and you get 2 to the power of 9. I've seen people get very confused between the two questions and try to write incorrect answers like 8 to the power of 9, which isn't correct. So we're going to finish off by looking at a quick summary of the 3 rules we have recapped so far relating to indices. So first of all, in our last lesson, we saw that if you have x to the power of a multiplied by x to the power of b, this can be simplified as x to the power of a plus b, because the base in each case, x, is the same. We also saw that if you have x to the power of a divided by x to the power of b, this can be simplified to x to the a minus b, again because you have the same base x. And in today's lesson, we've seen that if you have x raised to the power a or raised to the power b, you can simplify by multiplying the powers together, and you have x to the power of ab. Now, in this case, we do need to remember what happens if you have, for instance, and this is just an example, I picked at random, 3x to the power of, let's say, 7 here, all raised to the power of 2, then you need to remember that this will become 9x to the power of 14. So just an example there to remind us that yes, you do need to do 7 times 2 to work out the power of the x, but this must also be raised to the power of 2 in this example. Of course, other examples may vary with different powers and different numerical values involved.